You know, we're in the middle of this massive AI revolution, right? It's a tidal wave that is literally reshaping our world. But what if I told you that this entire multi-trillion-dollar industry, the very future of tech, could be grinding to a halt because of a single microscopic thread of glass? I mean, think about it. Artificial intelligence is absolutely everywhere now. From these huge language models that are writing text and creating incredible images, all the way to the supercomputers powering scientific breakthroughs. This whole boom is pushing our hardware to the absolute edge of what's possible.
It sounds crazy, doesn't it? How could something so tiny be a bottleneck for something so enormous? Well, the answer is hiding in plain sight, deep inside the physical skeleton that holds all of our modern electronics together.
Okay, so let's get into it. We're going to peel back the layers of an AI server and uncover this hidden vulnerability. And believe me, it all starts with a single, specially engineered glass fiber. So every piece of advanced tech, your phone, your laptop, and especially those beastly AI servers, is built on something called a printed circuit board, or a PCB. You can think of it like the city grid for electricity. It's the foundation that lets all the different parts talk to each other. Now here's where it gets interesting. If a PCB is like a slab of concrete, then this electronic glass cloth is the steel rebar running through it. It gives it strength, sure, but in the world of AI, it does something way more important. It literally dictates how fast and how clean our data can travel. So why all the fuss about this one material? Well, this isn't just any old glass cloth. The physics of moving data at mind-bending speeds puts extreme demands on it. And that has turned into one of the most critical components in the entire AI industry. And this chart right here, this shows you the heart of the problem. In AI servers, data is flying at over 100 gigabits per second. At those speeds, signals get incredibly fragile. Regular e-glass has what you could call high electrical friction. It just slows the signal down and messes it up. Only this special T-glass with its super low electrical friction can keep that signal pure. It's not just nice to have, it's absolutely essential. But hold on, it gets even more complicated. Because this glass cloth is, well, it's woven. This creates a tiny microscopic grid. If one part of your signal travels over a glass thread and the other part travels over the resin in between, they arrive at slightly different times. That tiny timing difference, called skew, can corrupt the data completely. It is a total nightmare for engineers, and it's called the glass weave effect. Okay, so we've established we have a material that is absolutely critical for AI, and there are no good substitutes. You can probably see where this is going, right? We're looking at a perfect storm that's creating a massive global supply shortage. Look at these numbers. The demand for this special glass cloth isn't just growing, it is exploding. We're talking about a projected jump of over 700% in just 2 years. The AI industry wants more and more and more, but the supply? Well, it's not flexible at all. And here's the kicker, why we can't just flip a switch and make more. First, the technology is basically locked down by just a couple of companies. It's an oligopoly. Second, if you want to build a new factory to make this stuff, good luck. That's a huge project that takes 2 to 3 years easy. And third, even the factories we do have need to shut down for months at a time for essential maintenance. And the result is? Well, it's basic economics 101. When demand goes through the roof and supply stays flat, prices skyrocket. And this isn't hypothetical. One of the biggest manufacturers just announced a blanket 20% price hike. That's a direct result of the AI boom squeezing the life out of the supply chain. So, who gets hurt the most in all this? This supply squeeze doesn't hit everyone the same way. The huge tech companies, they can just buy up all the supply they need. But what about the small startups, the university research labs, the real innovators trying to build the next big thing? For them, it's like a brutal obstacle course. They design some incredible new product, but then they find out they can't buy the special materials unless they order a massive quantity. Then the big factories turn them away because their order is too small and too complicated. All of a sudden, their innovation just hits a dead end. Now, this is a huge problem for the whole tech world. But a new kind of business model is popping up to fight back against this exact bottleneck. And it's designed specifically to help the little guy. It's called Agile Manufacturing Aggregation. The idea is actually pretty simple, but it's really powerful. A platform basically acts as a go-between. It collects thousands of small, custom orders from innovators all around the world. Then it bundles them together, which creates huge purchasing power. It completely smashes through that minimum order quantity wall.
And this new model, it directly solves every single problem we just saw in that innovator's gauntlet. These platforms can actually stock the rare materials themselves so anyone can buy them in small amounts. They give innovators a ticket into the high-end factories that used to shut them out. And they even offer expert engineering help to make sure designs actually work, which saves a ton of time and money.
So this brings us all the way back to our big question. At the end of the day, this story isn't just about one kind of glass cloth. It's about what happens when a critical piece of the puzzle becomes impossible to get and what that really does to the speed of innovation. The real cost of a bottleneck like this, it's not just a higher price tag on the circuit board. It's the prototypes that never get built. It's the startups that never get funded. It's the brilliant ideas that die before they even get a chance. If we want to keep progress moving, we have to make sure that everyone, not just the giants, has access to the tools they need